about acids and bases and the properties of both. We'll start off with a TED Ed video. If you want to click on this link or copy and paste it, you can watch that for yourself. There are 3 different types of definitions for acids and bases. For our purposes, we're going to only work with one, and that's called the Arrhenius definition of acids and bases. An Arrhenius acid is an ionic compound that has the ion, that its hydrogen ion is its cation. Acids have a sour taste. For example, citric acid, so like lemons and oranges and things that have a little bit of a sour taste to them, that's because of the citric acid. Acids will also be called indicators to change colors. Indicators are substances that will change color based on the pH that they're in. Acids will turn litmus paper pink or red. The type of the pH of an acid is going to be less than 7. Acids will react with metals in a single replacement reaction called corrosion. So whenever you see any kind of corrosion on anything, that's usually going to be a single replacement with an acid that's found in the air. Acids will react with bases in a double replacement reaction called neutralization, which we'll look at in a lot more detail later. Bases. An Arrhenius base is an ionic compound that has an OH or a hydroxide ion as its anion. Remember, this is called a hydroxide ion. Bases will have a bitter taste. Bases are usually slippery, and soaps are usually made with basic compounds, and that gives them the slippery feel. Bases will also be called indicators to change color. A base will change the litmus paper to blue. The pH of a base will be greater than 7. Bases will react with acids in a neutralization reaction. Name writing and formula writing for bases. You're going to use the typical rules for naming ionic compounds. Remember, we're also going to be dealing with charges when you're trying to go from the name of a compound to its formula. So NaOH would be sodium hydroxide. Magnesium OH, and here we're going to go from the name to the formula. So sodium hydroxide, magnesium hydroxide, and this would be aluminum hydroxide. Remember, aluminum has a +3 charge. Each hydroxide has a -1 charge. So our formula is going to be AlOH3 for aluminum hydroxide. If the anion ends in "ide", then we're going to change it to a certain ending. If it ends in "ate", we're going to change it to a different ending. If it ends in "ite", then we're going to change it to a different ending. So sometimes you're going to be having to look at the polyatomic ion sheet to see what is the formula for the acid, and then look at the name. So if it ends in "ide", we're going to change it to hydro and add IC on the end. If it ends in "ate", like carbonate, then we're going to change the ending to just IC, and it'll be something ic acid. If it ends in IT, then we're going to change the ending to OUS and put the word acid at the end. Let's take a look at a couple. For acids, you're going to look at the anion ending. That's a phosphite, that's a bromide, and that's carbonate. So this becomes phosphoric acid, hydrobromic acid, and because we have to come up with our formula, we've got to balance our charges out. This will be H2CO3. You'll have some practice on your worksheet to do that. Remember, the hydrogen ion is always the cation for acids. So it's always going to be the same. We're always dealing with hydrogen, hydrogen, hydrogen. The only thing that changes is the anion ending. Let's talk for a second about the pH scale. pH scale is the measure of the acidity of a solution. You can have things, anything that's less than 7, between 0 and 7, is acidic. 7 is considered to be neutral, and anything above 7 is considered to be basic. So on this side, you're going to have a lot of hydrogen ions. On this side, you're going to have a lot of the hydroxide or OH ions. pH is calculated using the negative log of the concentration of hydrogen ions. This symbol here stands for concentration. So when we have a bracket that looks like that, that indicates the concentration in molarity. We're going to use a PhET simulation to look at the basics of acids and bases. Neutralization reactions. A neutralization reaction is a double replacement reaction between an acid and a base, and it will always produce water and a salt, which is just another name for an ionic compound. Let's predict the products in words and formulas and then balance this reaction. So we have phosphoric acid plus calcium hydroxide. We can rearrange this and change this to hydrogen phosphate. We know it's going to be phosphate because we have ic on the ending, and we know hydrogen is going to be the cation. Calcium hydroxide is just the way it's written, calcium hydroxide. Well, we know it's always going to produce water plus calcium phosphate. Remember, it's a double replacement reaction, so the phosphate's going to bind to the calcium. The hydrogen is binding to the hydroxide to produce our water. So when we're doing our formula, it's going to be water plus, again, we've got to balance the charges to get our correct formula. Now we're going to balance it. We can also look at this as being HOH. In case we wanted, when we're balancing these things, just keep track of the OH, or hydroxide, and the number of hydrogen. When we balance this, we get the following numbers. In a titration, a solution of a known concentration, called a standard solution, is used to determine the concentration of an unknown solution. We're going to stop there and do titrations tomorrow.